Today I'm going to be talking about the ideas behind power. Now what power is power is the rate of energy transferred, so therefore we calculate it by energy transferred divided by time. As we know, energy transferred could be equal to the work done in a situation, so power is also equal to work done divided by time. Furthermore, if we think about it in more detail, that means force times distance divided by time. Now, this is a useful step because it means we can easily identify that distance divided by time could also be described as velocity. So force times velocity is also equal to that of power. Now, thinking about the units here carefully. Energy transfer divided by time is joules per second, or often known as the watt, named after James Watt, the Scottish scientist who helped dramatically improve the steam engine and introduced ideas of efficiency and power, and horsepower as it happens. Work is also measured in joules, and time is still in seconds. If we start to break down the units, we recognise that this is Newton meters per second, or Newton meters per second. And all of this is equal to force, equal to power. Now let's think about some questions which we might want to consider here. Question 1. A man of weight 800 newtons takes 1 minute to climb a staircase 21 meters high, travelling a distance of 36 meters in the process. Calculate his average speed, his average upward velocity, the total work done against his weight, and his average power. So we're going to consider these sets of questions. First of all, what have we been given in the question? So if I look a little bit more closely, we've been given the weight is equal to 800 newtons. We've been given his displacement, which is 21 meters. We've been given the distance travelled, which equals 36 meters. And we've also been given the total time it took, which was 1 minute, or 60 seconds. Now for each section, let's think about it step by step. Question A asked for his average speed. So speed is equal to distance divided by time. We know the values for distance and time. So distance is going to be 36 meters and time is going to be 60 seconds, which if we calculate through tells me that his speed is 0.6 meters per second. Now I think about his velocity. Velocity is equal to displacement divided by time. And here I can put in the information straight away, so I know that's going to be 21 meters. The upward displacement, his change in position, divided by 60 seconds. And again, that's going to give me 0.35 meters, seconds to the minus 1, in the upward direction. Work done. Well, work done is going to be force times distance. So work equals force times distance. But the thing I've got to emphasize here is we've got the distance which we're talking about in the direction against the force. So what we have here is 800 meters multiplied by 2100 newtons multiplied by 21 meters. So that's going to give me a total of 16800 joules. So final work done. Finally, power. Power is going to be equal to the work done divided by time. So I have 168,000 divided by 60, which actually gives me 280 joules per second, or preferably 280 watts. So there's one type of question which you might come across. Here's another question that you might come across. The engine of a car generates 35 kilowatts at a maximum speed of 140 kilometers per hour. Calculate the force acting against the motion of the car at this speed. Now, to do this, what we need to think about first of all is what we've been given, and then try and work that through. So the given information to us. We have been given two things. First of all, we've been given the power. Power equals 35 kilowatts, which is obviously equal to 35,000 watts. We've also been given the velocity. Velocity equals 144 kilometers per hour. I'm obviously going to try and convert this into meters per second. So I will have this as 144,000 meters divided by the number of seconds in an hour. 60 times 60, which all comes out at a lovely value of 40 meters per second. The value I'm looking for, my unknown, is force. What is the force which needs to be applied? So the equation I need to use is power equals force times velocity. Therefore, force equals here. Just 1 moment, I'll tidy that up. Scribble that. Force equals power divided by velocity. All I need to do now is substitute. So if I substitute in, we have power equals 35,000 divided by 40, which gives me a number of, let me just tidy up those O's, of 875 newtons.